Right, little introduction that you don't have to interpret about the speech. This is a speech about Swiss innovation to save energy and to produce energy more efficiently. So done in Switzerland by people who are maybe Swiss, but who all have very foreign sounding names. Right, I'm going to give you a couple of words and their names. Perhaps I'll start with the names. So you can write these down however you want. Just make sure you can get the right sound from what you write. Dejan Kostic, Nedjelko Vazic. So Dejan Kostic, Nedjelko Vazic. Ari-Pekka Hamari. Fernando Porte Argel. Colin Jones, and that's it for people's names. Now the terms. Internet service provider, ISP. Car production line, maybe. CERN is the European Centre for Nuclear Research. It's based in and around Geneva. I say around because it goes under the border in France. That's not really relevant here. You have the EPFL, which is the École Polytechnique Fédérale de Lausanne. Polytechnic really doesn't mean the same thing in Switzerland as it would do in the UK. This is one of the best schools in Europe for engineering, architecture, loads of stuff. And you also have the EPFZ. It's a French acronym, come to think of it. I suppose there's a German one, that's the only one I have, which would be the École Polytechnique Fédérale de Zurich. You've got wind tunnel, Deus Ex Machina, energy transition, if that's really a thing. Wind tunnel is soufflerie in French. I don't know if that helps at all for the Italian. Galleria del Vento. Here we go. That's nice. Okay. Right. Let's make a start then. Ladies and gentlemen, as you may know, I'm half Swiss. And this morning we're talking about energy and the environment. And I thought I would tell you a little bit about the contributions that Switzerland is making to the world of energy, and more specifically about how we can reduce energy consumption in some areas and optimize energy production in others. There are a number of Swiss scientists who are looking into the issue of energy. Some try to make sure that the amount of energy used for the internet remain reasonable, and others working on projects that try to optimize wind power. You may not know this, but the internet uses a lot of energy. The amount of information it contains and the circulation of this data mean that you need to use a lot of energy to keep this going. And the data and the circulation of data I was mentioning a second ago is constantly increasing. You have more data moving around, and therefore the amount of energy the infrastructure uses is also increasing. So much so that it's actually becoming a concern for the economy and the environment. Based on a 2009 study, just in Switzerland, it's been observed that the internet used 4.6 terawatt hours per year. That's about 7.8% of the country's total yearly energy bill. It takes the entire production of a nuclear power plant to keep the internet going for Switzerland. And this is a trend that also applies to the rest of the world. So what are Swiss scientists doing? Well, or Swiss-based scientists. Dejan Kostic is a professor at a laboratory that works on networks at the EPFL, the École Polytechnique Fédérale de Lausanne. Since November 2012, he's also been working at an institute in Madrid that also works on networks, and he deals with this huge amount of energy that the internet is using. That's what his research focuses on. Together with Telefonica Research, based in Spain, and with another researcher called Nedeljo Vazic, he's put together the response system. And this system could allow us to save 30 to 40% of the energy used by computers. How does this actually work? Well, his explanation is that the way networks have been set up means that they are based around two concepts. One is redundancy, and the other is a huge bandwidth. What that means, the point of this, is that it's able to handle huge variations in traffic. So you can get a very small demand at a given point and a huge demand for traffic, for data traffic, 5 seconds later. So the systems are able to cope with whatever demand is thrown at them. But what that means is that most of the time, those systems are working in the least efficient way possible. So this response system is about optimizing this costly system, this costly way of doing things. What it does is that it calculates ahead of time how much information is going to be routed in a certain direction. And you have an online mechanism that activates and deactivates points of the network on demand based on whether they're used or not. I hope you're still following me. It's not the easiest part of my speech, this. So these researchers have shown that this system, if used for computer networks, can bring a better result than the systems that are already in place. And the advantage is it has barely no impact. It has barely any impact on the responsiveness of the system, on the performance of the system. There's another element they're looking into, and that's upstream, and it's all the modems, the routers, what have you, that are involved in the network. Now, all these little gadgets don't consume a lot of energy individually, but actually all put together, they represent 3/4 of the entire amount of energy that's used by the internet. Dejan Kostic's team's solution, that's a very roundabout way of saying it. His team's solution has been simply to find a way of putting all these gadgets on sleep mode whenever they're not being used. And that's also something that internet service providers can do on an upstream level as well. It's believed that if this were applied worldwide, 33 terawatt hours per year could be saved. That's the amount of energy that 3 nuclear power plants can produce. Right, fast forwarding a bit. Let's now look at what we're doing in terms of wind power. Now I want to talk to you about another researcher called Fernando Porte Agel, who works on wind power engineering, still at the EPFL. His research doesn't look into how you can try and consume less energy, but rather how to produce as much as possible. What he does is, what he's trying to do is to set up a simulation model, a digital simulation model for air turbulence. We're talking about turbulence on a rather small scale, but apparently small-scale air turbulence can have an impact on wind turbines and therefore the energy they produce. The idea is that you can optimize the way wind farms are designed, all the while measuring the impact that a wind farm would have on the local weather at the same time. According to the scientist, we already have a pretty good understanding of airflows on a scale ranging from a kilometer to a meter, but it's below that scale apparently that we can still optimize things. There are a number of digital solutions that have been put forward over the years, but the problem apparently is that they don't really adapt to every weather scenario. Whereas here, Fernando Portiacel and his team think that they've found a system that actually works in any scenario. And there's also worth mentioning there's another study they've carried out in a wind tunnel, and with this one they were able to determine that their simulation for the way the air flows around a wind turbine was correct and actually matched reality. Moving on now to another wind energy related project. This is Colin Jones, who is a lab assistant still at the EPFL. He doesn't look so much at local weather patterns at the ground level. That's because what he is looking into is how to produce energy based on very high altitude winds. Well, very high, looking about 100 to 150 meters high. And the idea is to use kites, believe it or not. Together with a team from the EPFZ in Zurich, they've set up a system that looks a lot like kite surfing, except instead of someone on a board, you've got a lorry with an electricity generator on the ground. Now, why would you want to use high altitude wind? Well, apparently it's much more stable and much stronger than what you get close to the ground. So that can make it much more interesting. The way it works is that you have your kite, your lorry on the ground, and it's because the cable between the two moves that you get movement, and out of that movement you're able to generate energy. And what this researcher is looking into is a way of automatically controlling the kite, the wing that's up in the air. And especially he wants to find a solution to make it work even when the weather gets extreme up there. So ideally you could almost have an autonomous system. You wouldn't have to have someone monitoring it constantly and having to reel it in if the wind gets too strong or unstable. So there are actually a number of teams throughout the world working on this type of project, but so far none of them has been successful. So to sum things up, or to conclude, these 4 projects don't actually, or the leaders of these projects don't actually believe they're going to solve energy production on their own. Most experts actually, agree to say that it's not some technological deus ex machina that is going to solve the issue of energy production for us. However, they do think that all these small solutions can add up together and take us closer to a successful energy transition. And this goes two ways, as I've given you examples of. On the one hand, improving energy production, improving current technology that we have, making it more efficient, for example, photovoltaic panels, batteries, etc. And it also involves reducing our energy consumption. Thank you.
Poi ho pensato al calciatore di Aquiloni di Qualcuno ti ha ascoltato? Chi è che mi ha ascoltato?